Now, the next thing we may have to do is to calculate resistance in series circuits. And in a series circuit, the total resistance is just the addition of whatever resistors are there. So in other words, if you increase the number of resistors in your circuit in series, you increase the total resistance in the circuit. And that's very similar to taking a length of wire, making it longer and longer and longer. That will increase the total resistance. So in this circuit, we're going to just add up the two resistors, R1 and R2, and that's equal to 4 plus 2, and your answer is 6 ohms. So that's a very straightforward thing to do, add resistors in series circuits. Resistors in parallel circuits, however, for two resistors, the total resistance is, we call that the product over the sum. Okay, so that's equal to the product over the sum. So how do we do that? We have to multiply the two resistors and divide by them added. So if I put a bracket around these, you'll realise you have to do the top line first. I'm just going to continue that there. Divide by the bottom line. So we go at this circuit, we've got 4 and 2 ohms here. What is the total resistance for the circuit shown? And the total resistance is 4 times 2 over 4 plus 2. And that's giving you 8 divided by 6, which comes out as 1 1/3 ohms. Now, the interesting thing about this answer is that this answer is always less than either of the two resistors there that are shown in parallel. So the total resistance is always less than the smallest resistor that's in parallel. So it's smaller than 2. 1 1/3 is smaller than 2. And that means that whenever you add resistors in parallel into a circuit, you're actually decreasing the total resistance. Now, the way we think about that is that you're providing, the more resistors you add in there, you're providing more and more paths for the current. When the current comes around here, it splits up, as you remember from the first topic. And you're providing more and more paths. It makes it that bit easier for the current to pass through, and therefore the total resistance decreases. And the answer is always less than the smallest resistor that's in the parallel bit. So if you had 100, 40 and 2, the answer would still be less than 2. Now this rule only works for two resistors in parallel. I'm just going to show you two equal resistors in parallel, because there's another thing that happens here which is a very handy thing. So if we do the product of the sum over the sum, that's a total resistance. 8 times 8 over 8 plus 8 gives you 64 divided by 16, which gives you 4 ohms. So again, the 4 ohms is less than the smallest resistor that's there, but if you notice, it's half of one of them. And I'm going to do it again. I'm going to change those and say that those are, we'll make them 10 ohm resistors. And do it again. 10 by 10 over 10 plus 10. So that's going to give you 100 over 20. And that gives you an answer of 5. And guess what? 5 is half of one of these. So if you have equal resistors in parallel, the answer is always half of one of them, if they're equal resistors. Okay, now the product over the sum rule only works for 2 resistors. And whenever you come to 3 resistors, then you have to use your... Now this diagram shows 3 resistors in parallel, and we're going to put values on them. I'm going to make the values the same, so I'm going to make them 3 4 ohm resistors. Now, whenever you do this, you have to do this using a different rule. And the rule is we have to do it as fractions. 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus, if you had any more, you would just keep going. So we're going to do this just first of all with 3 equal resistors, just to see how it comes out. And I'll do it on this side of the page. So 1 over RT is equal to 1 over 4 plus 1 over 4 plus 1 over 4. And that is equal to 3/4. Now, if those weren't 3 equal resistors there, you would have to find a common denominator there. So that's 1 over RT. So we have to flip that upside down. So RT is equal to 4 over 3, which is 1 1/3. I should have chosen a better number there. But whenever you look at that, 1 1/3 is actually 1/3 of 4. So if when you have 3 identical resistors, the answer is 1/3 of one of them. And if you had 4 identical resistors, so that's 3 identical. If you had 4, I'm sure you've already worked it out, then the answer is 1/4 of one of them. And so it goes on. Now, I'm going to change this and use different values. So I'm going to use 4, 4 and 8 this time. So I'm going to change that resistance there to 8 and do my calculation again. So what is my total resistance? So it's 1 over RT is equal to 1 over 4 plus 1 over 4 plus 1 over 8. And you have to find a common denominator, and obviously it's an 8th. So you have got 2 eighths plus 2 eighths plus 1 eighth, and that gives you a total of 5 over 8. But that's 1 over the total resistance, so you must turn it upside down, and it's 8 over 5, or 1 and how many fifths? 3 fifths, or 1.6 ohms there. Now, again, there's your answer, less than the smallest one that's there. So 1.6 is less than 4 ohms. So you have to use this rule whenever you are using more than 2 resistors in parallel. So it will work for 4 resistors, 5 resistors, and so on. And again, this identical resistors thing works. You just divide by the number of resistors that are there. You divide one of the values, and that gets you your answer here.